Hey, Donovan, are you in incognito today? Donovan,
Hello.
are you incognito today?
No.
No? Then why does it say Candace on your thing?
Because my siblings accidentally messed my computer up, so I'm using my mom's.
Ah, your siblings? God bless siblings. Younger brother.
Hmm?
I was a younger brother.
I'm the oldest.
My oldest brother hated me. Could not stand me. You know, the one thing in life that he would have been happy with is to be an only child.
I feel it.
Yeah, I'm sure you do. Okay, guys, what I'm going to do tonight, we're doing nomenclature, right? Nomenclature. All right, first of all, I'm going to scare the hell out of you by showing you what you have to go through. There are 127 questions. Mila, I bring this to your attention. 127 questions. When you go to do this, I want you to put your children in a cage so that you're not disturbed by them. Actually put the dog in there and the best, let the best one win, okay?
All right.
No, seriously about this. It's 127 questions. I kid you not. So I disagree with it. When I first did this quiz, I did do it maybe 7, 8 years ago. I got to question number 90 and then I didn't give a shit anymore. I'll be perfectly honest with you. I didn't care. I just was so fatigued by this that I don't see the relevance of giving you this many questions because you guys will get fatigued as well. I understand that, but just do the best you can. And the only thing I can tell you is to just be aware that that's what this is. I'm in to the course. I'm going to course content now. And we're going to nomenclature. Nomenclature report. If you thought I was kidding you, I am serious, ladies and gentlemen. I am not happy with this, but it is what it is. You have to do this in one sitting. This doesn't mean you can't go away and then come back to it, but it has to be done in one sitting. There we go. Question 1, all the way down. If you thought I was kidding you, I am not. There are 127 questions. First question doesn't count. They are all multiple choice. And believe me, it gets absurd at times. Trying to find, okay, look at that OH one has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 choices. Don't shake your head at me, Allie. All I'm doing is I'm just trying to make you aware. SO4, guys. This one, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, something like that. 9, 10, something like that. Just be aware that this is there and you will get fatigued. You don't want to have anybody like siblings, Donovan, You don't want siblings around. You don't want dogs or cats or children. I'm sorry to say that, but you want to just do this at some time when it's a quiet time. Any questions about the magnitude of this thing? All right, the way I like to do the lab portion, I've already told, basically, if you have me for lecture, you're going to get the same information over again because this is just the way I teach it. What I'm going to run this as is a workshop. So I do not mind if you want to cut out. I don't mind that at all. Let me get done with the roll from the beginning. Lewis, you out there?
Yes, sir. Here.
Christina,
Here.
Nathaniel,
I'm here.
Kelsey, Marie, Donovan's here. Matt,
Sorry, yes, I'm here, Marie.
I gotta yell at you.
Sorry.
I get this email on Saturday saying, "Where's my quiz? Why hasn't my report been? For God's sakes, you have a whole week to do this. You're not going to even give me the same courtesy."
Sorry.
Usually, Marie, to be honest with you, I usually don't get to them until Monday. Monday, I have kind of a free day, so that's when I usually get to your lab reports. So
Okay.
just to be aware of it. All right.
Okay.
Okay, Marie is here. Maxwell. Armithia.
Here.
Nyla. Kaylin, I saw Elizabeth. Malin.
Here.
Jordan.
Here.
Mariah.
Here.
Aaron, I saw. Michael.
Here.
Thank you, Michael. Sheridan, I saw. And Nyla's now in here. Mila's here. Alec. Brian.
Here.
Sarah is not here, correct? Ali, and I saw Andrew. Okay, so I don't have Kelsey, Maxwell, and they haven't been here for a while. And I'm fairly certain we're not going to see Sarah anymore either. Okay, ladies and gentlemen, I'm going to start this by doing the back end first.
Quick question. What do you mean by checkout, like log out?
Yes,
Okay.
if you leave the screen on and you can trust your screen, then it will still be there. It's not gonna log out on you, I don't believe, okay?
Okay.
All right, that's driving me crazy. Back in 1 second, guys. No, I won't. It's God bless answering machines. Okay. Okay, you have an opportunity for extra credit today. After you get done with the 127 questions, should you so desire, there is an extra credit quiz on electrolytes. And that's what I'm going to start this off with because if anybody wants to cut out, that's fine. I just know that I haven't given the electrolytes first, so I'm just going to do that information first. So without further ado, if you do not have it, what I need in front of you is a periodic table, a listing of the polyatomic ions. I don't care if you get it from your survivor guide or if you get it from the laboratory manual. Either one will work. You also need a listing of the prefixes for the covalent compounds. I want you to have those in your hands because we're going to do the main portion of this like a workshop. All right, now I got to find the other thing. Ladies and gentlemen, that great megalopolis university to our north is responsible for the development of that wonderful sports drink known as
Gatorade.
Gatorade. There was a guy by the name of Robert Cade, and basically he got a request from the Florida coach, and the Florida coach noticed that all of his athletes were cramping in like the fourth quarter. So he asked this guy to kind of develop something to inhibit the cramping. And what they had done through research is they realized that muscles fired because of something called electrolytes in your system. A body isn't wired with copper. What carries current in the body are something called ions. Okay, and this guy, Robert Cade, decided that if you replenished the carbohydrates and the electrolytes, they may be able to eliminate this cramping. Makes sense because muscles fire from electrical signals, and these electrical signals are carried by ions. So if they're not firing on command and may fire outside of your command, we need to replenish those ions to avoid that. The only trouble is you're getting those ions in liquid, and most of the ions get eliminated from the body before they can replenish themselves. That's just a little sideline. Ions are a way to complete an electrical circuit. Cations go towards the positively charged pole, anions go towards the negatively charged pole. And the negative ions help to push the electrons along towards the cathode. But in order to do this, the circuit must be completed by a sea of ions. You have to have ions between the two poles, or else you don't have a complete circuit. So what happens is they start from this side, the negative ions go drifting towards the other pole. That completes the circuit. So in order to complete, you need the sea of ions. So for a compound to be an electrolyte, it must be ionic. Now, the strength of the electrolyte is going to be dependent on how readily it dissolves in water. A strong electrolyte dissolves fairly readily in water. A weak one is fairly insoluble in water. So if you see something with light that's really, really bright, that means it's a strong electrolyte. A dim light means that you have a sample that's a weak electrolyte. It doesn't dissolve very well in water. Now, the next thing we have to do is we have to learn part one of your pages in your laboratory manual has it that you have to split the ionic compounds into their ions. One of the things you have to realize is if you have an ionic compound, the first element will always be a metal, except one exception. And that exception is the polyatomic ion NH4. That will be the only time you have a polyatomic ion that acts as a cation. Everything else is going to be a metal if you have an ionic compound. So basically, all you got to do is look for the metal. Everything else in the compound is going to be the anion. So if I'm splitting these compounds into their respective ions, I take the metal, and I got to tell you how many of them there are and what the charge is. First metal in KCl is potassium. There's no subscript, so that means there's only one of them. I look in my periodic table, I find potassium's in the first column, so that has a +1 charge. I then look at everything other than the potassium, which in this case is just Cl. I find Cl. Cl is in column number 7, the one that is just to the left of the last column in the periodic table. Everything in that column is a -1. So if I'm looking at this, subscript is 1. I have 1 Cl minus. Next compound down. First element is magnesium. I find that one in the second column of the periodic chart. Being in the second column, that means it has a +2. Again, no subscript. So for this magnesium, to split that into an ion, it would be 1 Mg2+. I look at everything else, which is the anion. I have I2, I subscript 2. This means there are 2 of them. Again, if I look at the iodine, it's also in that 7th column. So its charge is -1. So if I'm splitting Mgi2 into its ions, 1 Mg plus 2, 2I minus 1. Are you getting the idea of how we're splitting these things up? Michael, you out there, Michael?
Yep.
Okay. We have AlNO3 taken 3 times.
Okay.
How many ALs do we have?
That would be 6 then, correct?
Nope, nope. All you're doing is looking at the subscript.
Okay. So then that would be that would be 1 AL then.
1 AL. Okay. Now, do you know off the top of your head what the charge of AL is?
I mean, not off the top of my head now.
Okay, it's one of the 4 I make my students remember. Now they're going to make me proud, right? Kaylin, you're going to make me proud, right? Kaylin,
Proud. Yay. Hi.
what's the charge on AL?
+3.
So, Michael, AL, there's 1 AL plus 3.
Okay.
Do you have your polyatomic chart with you?
I do.
Okay, NO3. You got, in order to call it an anion, you have to include everything in that polyatomic. So if NO3 is in parentheses, everything within that parentheses is your polyatomic anion. Okay, Michael, how many of them do you have?
Of just NO3.
Of just NO3?
Well, I know that it's a -1 charge, so do I have to, does that have anything to do with this answer?
No, well, it will come into play. Yes, it is a -1. But how many of them do we have?
3 of them.
3 of them, absolutely. Because outside of the parentheses, there is a little subscript 3. So I have 3 NO3s, and as you told me, it has a -1 charge. So to split AlNO3 taken 3 times, 1 Al plus 3, 3 NO3 minuses. Oh, now we're getting into some hard stuff. Andrew. Andrew.
Yeah.
Split this into its ions. What's the positive ion? Positive ion's always going to be the metal. What's the metal in that compound, Andrew? Andrew, I don't know. It's a perfectly good answer.
I don't know.
Okay. I don't know. It's a great answer. Now, do you have a periodic table in front of you, Andrew? Okay, good. Now, do you see where the staircase is? The little stepping star, or the little staircase. You see where that's at on the periodic table?
Yes.
That splits things into metals, which are on the left and below it, and non-metals, which are to the right and above it. Do you see where Ca is in the periodic table?
Yes, it's under the metals.
So metals are going to be your positive ions. How many Cas do I have, Andrew?
3.
3. Ca. Now, which column is the Ca in?
Second column.
The second column means it's going to be a +2. So to define this atom into its ions, it is, give me the number. How many of them are there, Andrew?
There's 3 of them, so it'd be 6.
No, not 6. It only, the subscript only defines the elements or elements that are directly to their left. This 2 has nothing to do with it. This 2 has nothing to do with calcium. So how many of them do I have?
3.
3 calcium +2s. Okay, Andrew?
Yep.
Now, what's the anion? Remember, everything other than the metal is going to be the anion.
The PO3.
PO3. How many of them do you have?
Three.
Nope. What's the subscript, Andrew?
2.
2. Okay. There are 2 there. So we have 2 PO3s. Do you have your chart, your polyatomic chart with you? Somebody help him for a second, okay? PO3, what's the charge on PO3?
2 plus.
-3.
Minus 3. So Andrew, the anion is going to be 2 PO3s, 3 minuses. Okay? Marie, this is a tough one, Marie.
Yes.
PB3N4.
Okay.
What's the how many of the cations do we have?
1.
Again, we have to look at the subscripts.
Oh, cation. Oh, sorry. 3.
3. What is the cation?
Excuse me.
What is the cation?
Lead.
PB. 3
Mhm.
PBs. Do you know what the charge on the lead is?
2 plus.
Nope.
Oh, let me see. Let me
You're not
check.
going to find it there, Marie.
Oh, 4.
4. There are 2 ways to figure this out, guys. And we'll get into that a little bit later. But one of the ways is to cross these things. The subscript on the anion will be the charge on the cation. The subscript on the cation will be the charge on the anion. So if we're dealing with the cation for PB3N4, 3 PB plus 4s. Marie, how about the anion? How many of them do I have?
4.
4.
Mhm.
What is it? What is the anion?
And nitrogen.
Nitrogen. What's the charge on nitrogen?
3 minus.
3 minus, finest kind. Okay,
Okay.
let's see. Brian,
Yes.
all right, Hg2SO4.
Okay.
How many of the cations do I have?
You have 1 Hg.
One? What about, what's this little subscript
two,
down there
two.
means? Okay, 2 Hgs. Okay. Do you know what the charge on SO4 is, Brian?
-2.
-2. So if the SO4 is a -2,
Is
means that-
Hg +4?
nope.
No.
The -2 balances with what? The Hg2SO4 is a neutral molecule. So if SO4 is a -2, what positive charge has to balance that?
+2.
+2. But that's distributed in how many Hgs?
2.
So if the total positive charge is a +2 and you have 2 of them, what's the charge on each one?
Plus. Wait. Can you
The
say that
tot-
again?
The total positive charge is +2. That's distributed amongst 2 Hgs.
Mhm.
So what's the charge on each one?
Would it just be +1?
+1.
Alright.
So I have 2 Hg +1 plus SO4 2 minus. And I have no idea what that's for. I think yeah. No idea why that is. Okay, ladies and gentlemen, that is electrolytes. You have the ability to get, I believe it's up to 5 points extra credit. And the quiz is not nearly as horrible, but you're still going to deal with around 30 questions or so. Other thing, you need to watch the video in order to determine what your reactions are. So you're going to go in course content, nomenclature, and you're going to go down to the electrolytes results video. And I got to get this back on here. What he does.
Next one we're looking at is sucrose.
Okay, what he's doing. He's got a light bulb attached to an electrical circuit. The only way the light bulb is going to light is if there are electrolytes in the solution. So you're going to go through, it's a minute out of your lives, guys.
All right, this one is acetic acid. This one is hydrochloric acid.
Okay, do you see the difference between those two? Hydrochloric acid is a strong electrolyte. Acetic acid is a weak electrolyte. So every time you see a reaction like this, you're going to put strong electrolyte on it. Every time you see a reaction like nope, not like that. That is acetic acid. That is a weak electrolyte. You are still getting an electrical signal, but it's not that strong. And if you have a non-electrolyte, you're going to get no reaction. Remember I said, in order for something to be an electrolyte, it has to be ionic. So is sucrose an ionic molecule? This is a minute and 13 to get through this video. Okay, ladies and gentlemen, when I talk about nomenclature, I like to talk about a series of questions. Okay? I have a series of questions which will tell me which rules I need to follow. And once I know the rules, how I go about naming it. So again, I need you to have a periodic table in front of you, a listing of the polyatomics, and a listing for the prefixes for the covalent compounds. There are two major types of compounds, ionic and covalent or molecular. They use different rules. So what you do, you look at the first element in your compound formula. If it's a metal or NH4, you have an ionic compound. Use those rules. If the first element is a nonmetal, you have a covalent compound. Use those rules. So the first question you're going to ask, is the first element a metal? If it is, ionic rules. If it is not, covalent rules. If the answer to your first question is it was a metal, you have to ask yourself a second question. Is the metal a type 1 or a type 2 metal? For type 1 metals, you know the charge. If the metal lies in the first column of the periodic table, those are all alkaline metals. Those all have a +1 charge. If the metal lies in the second column, those are all alkaline earths. Those all have a +2 charge. And I have you memorize 4 others. Silver always is going to be +1. Zinc will always be a +2. Aluminum will always be +3. Cadmium is a +2. Now, guys, I don't know if I've told you this before, but I am lazy. I am one of the laziest creatures on earth. If I don't have to do something, then I'm not gonna, and you're not gonna make me. I already know how much the charge is on the first column, the second column, or silver, zinc, aluminum, or cadmium. I already know the charge. It's worthless for me to try and name that charge afterwards. So if it's a type 1 element, do not use a Roman numeral. Type 2 metals, everything other than what I've defined. These are mainly the ones that are in that transitions, the ones that are kind of like in that pool down below where it kind of dips down there. They're generally going to be in there. Type 2s, you do not know the charge. You have to determine what the charge is and then define it by calling it a Roman numeral inside parentheses. So if I have a type 1, to name it, all I have to do is just name the metal. Calcium is calcium. Magnesium, magnesium. Sodium, sodium. No Roman numeral after it. If I have a type 2, I have to determine what the charge is on that type 2. Then once I've determined that charge, I put the charge inside parentheses as a Roman numeral. My cation is named. Third question. First of all, you need to understand everything after the metal or the NH4 plus, everything after that is the anion. The next question you do, you look at that anion and ask yourself, is it composed of one type of element or more? If it's composed of one type of element, to name it, you take the root. The root of the name is going to be the first syllable, followed by IDE. If I have Cl, Cl is chlorine. First syllable is chlor, follow that by IDE, chloride. Oxygen, oxide. Phosphorus, phosphide. Now, if I look at the anion and I see that the anion has more than one type of element, it's polyatomic, which means there's good news and bad news. The good news is, to name it, you just name what the polyatomic is. If you see SO4, it's sulfate. If you see CO3, that is carbonate. You just name it. Now, with good news, there always comes bad news. The bad news is you got to memorize them. Anybody out there, does anybody's lecture teacher making you memorize the anions? This is something you need to ask. You need to pin your lecture teacher down to see if they're making you memorize the anions. If so, you just have to live and bear it. You just have to go and memorize them. If not, make sure that you write them on a piece of paper somewhere to take them in for your test. I'm going to give you a listing of them. The reason I give you this is so that you have some sort of a rapid source to access them. You also have the source that's in your lab manual, and you have your source that I believe is on page 7 of your survivor guide. Module 5, page 7. These are all the ones that are negative, not all the ones. These are the common -1 polyatomics, -2 polyatomics, the common ones, and -3. Okay. I have this compound, Ag2O. Is the first element a metal? Yes. Ionic rules. Is the first metal a type 1 or type 2? It's one of the 4 special ones. It is a type 1. Because it's a type 1, I do not need a Roman numeral. I just name the metal. Silver. I look at the anion. The anion is composed of one type of element. It's a monoatomic. I need the root plus IDE. It's oxygen, oxide. Whole name, silver oxide. Let's see who I haven't picked on. Aaron, I haven't picked on you. In ages, Aaron.
My mom's actually vacuuming right now, so I can't really hear anything at all.
A likely excuse. Jordan. I'm kidding you, Aaron. I'll get you later. Jordan, you're out there, Jordan.
Yep.
Okay, Jordan. We're going to look at this molecule. Okay. Is the first element a metal or not?
Yes, it's a metal.
So is it ionic or covalent rules?
Ionic.
Okay. Now I'm looking at that element, iron. Is it in the first column, second column, or is it silver, zinc, aluminum, or cadmium?
No.
So is it a type 1 or a type 2 metal?
Type 2.
What do type 2s need?
Roman numerals.
How do I get the Roman numeral? What does the Roman numeral stand for?
The charge.
The charge. I got to figure out the charge. Okay, Jordan, do you have your polyatomic chart there?
No, sir.
Nope. Do you know what SO4 is? What the charge on SO4 is? No, it's a perfectly good answer, Jordan.
No, sir.
All right, somebody please tell Jordan what the charge on SO4 is.
-2.
-2, Jordan. Okay, we got that?
Yes.
Okay, so if in order to determine the charge of the cation that we don't know, we have to use the anion that we always do know. The charge on SO4 is 2-. So if FeSO4 is a neutral molecule, and it is, that means there's no charge. Since there is no charge on it, if SO4 is a -2, what does the charge on the Fe have to be?
+2.
+2. So that 2 gets put as a Roman numeral after the element name. So please name the cation for me.
Iron 2 sulfate.
Iron 2. Now you have to look at the SO4, find it in the polyatomics. You find it is sulfate. So as you said, Jordan, absolutely great answer. Iron 2 sulfate. Is this making sense, ladies and gentlemen? A little bit.
Yes.
Anybody want to volunteer for one? Yeah, I saw you sneak a look at me, Kaylin.
Okay.
Mariah, you out there?
Yeah,
Hi there. You want to give this a try?
sure.
Okay, Mariah. Is the first element a metal?
Yes.
We're using ionic rules. Okay. Is it a type 1 or a type 2 metal?
Type 2.
Type 2. What do I need?
Roman numerals.
Roman numeral. I got to figure out what the charge is. So I'm looking at this, I'm looking at the anion because I need the anion to figure out the charge so that I can figure out what the cation charge is. Okay, Mariah?
Is it a 4 positive?
Absolutely. Now, you did that. You made 3 jumps on me, so I'm going to go and explain how you did that. You knew that sulfur was in -2 charge. There are 2 of them. So the 2 multiplied by the -2 gives it a total -4 charge. That has to be balanced by a +4 charge. There's only 1 tin, so the charge on the tin is a +4. Good, Mariah. Now, Mariah, name it. Name the cation.
10,4 sulfide.
Guys are good. You're just doing this. You're going straight up. Yes, it is 10,4 sulfide. If you didn't know how to name the anion, you look at it. Even though there are 2 sulfurs, it's still the same element. So it is monoatomic. To name monoatomics, first syllable IDE, sulfide. It was sulfur, break it off, sulfide. So as you said, Mariah, 10,4 sulfide. Now, getting the second set of rules. If the first element is not a metal, you have to use covalent rules. Covalent rules involve prefixes. Ionic have no prefixes. So if you have a metal, don't use prefixes because metals are ionic compounds and they don't take prefixes. Covalent rules have prefixes. Mono means one, di 2, tri 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. If you got more than 10, it's predicata. Didn't like that, did you, Costina? You will never. I'll tell you what, if your lecture teacher, I won't give it to you, but if your lecture teacher gives you something with more than 10, tell me and I'll go and slap him for you. You won't get more than 10. Covalent, when we're naming them, you look at the first element. Look at the subscript on the first element. If there's no subscript, that means there's one of them. No prefix. If there's more than one prefix, add the element name. Then we're going to go on to the second element. The second element will always have a prefix. Look at the element. Use the root, the first syllable. End it with IDE. S3I5. First element, not a metal. I'm using covalent rules. The first element has a subscript 3. This is more than one. I need a prefix. The prefix for 3 is tri. So the first element is named trisulfur. Second element has a subscript 5. It needs a prefix, followed by the first syllable, followed by IDE. The 5 is penta. The element is iodine, so it's pentaiod. End it with IDE, pentoiodide. Put it all together, trisulfur pentaiodide. So I'm going to go through 2 sets of questions. If you get a metal, if it's a metal, you use ionic rules. You ask yourself type 1 or type 2 metal. If type 2, figure out the charge, then name it with the Roman numeral if it's a type 2. Then look at the anion and ask if it's composed of more than one type of element. If I have the question answer, no, it's not a metal, you use covalent rules. Are there more than one of the first element? Does it need a prefix? Name it. How many of the second element are there? Which prefix do you use? Add the root and IDE. B8, BR2. Elizabeth, you out there, Elizabeth? Once, twice. Mila.
Yes.
Have you put the kids in the cage yet?
No, I'm sorry.
Okay. For later then. All right, let's look at this. Let's look at this compound. Ba, Br2.
Okay.
Is the first element a metal?
Yes.
Yes. Do we use ionic or covalent rules?
Covalent.
If it's a metal?
Ionic.
Ionic. Okay. Ba, is it a type 1 or type 2 metal?
Type 2.
Look in the second column of your periodic chart, Mila.
Type 1.
Type 1. Do I need a Roman numeral?
No.
What's the name of the metal?
Barium.
Barium. Okay, now we're going to look at the anion. Is the anion composed of more than one type of element?
2, right? So
There are 2 of them, but is it the same element?
yes.
So if it's the same element, it's composed of one type of element. Okay, Mila? If it's composed of one type of element, you use monoatomic rules for it.
Yes.
Which means, do you know what the element Br is?
Yes, it's bromine.
Bromide. Bromide, yes, exactly. So the whole name of the compound, Mila, is
Barium bromine.
minus
Okay.
kind.
Sweet.
Donovan, I haven't bothered you in a while. Donovan. Going once, twice. Nathaniel, you out there, Nathaniel?
All right.
Okay, Nathaniel. You're doing Cl2O7. Is the first element a metal?
Let me find it on the table. No, it's not.
Do I use ionic or covalent rules?
Covalent.
Does that mean I use prefixes or not?
I believe you do.
Yep, absolutely. Is there more than one of the first element?
Yeah, there's two.
So what prefix corresponds with 2?
Great question. Is it
Isn't
bi?
it a great question?
I'm sure it's bi. I'm guessing bi.
No, it's not bi.
Is it really not? Okay, let's see here. Oh, it's di. There we go.
Di.
There we
Okay?
go. Yep.
So di, then you follow it with the name of the entire element.
Okay. Dichlorine.
Dichlorine. Now we're going to
Okay.
go to the second element. How many of the second element are there?
There is 7, which is hepta.
Hepta. Okay.
And then
what's-
oxide.
Oxide.
Cool.
Putting it all together, dichlorine heptaoxide.
Yep.
Okay. Christina.
Fantastic. Yes.
All right. Is the first element a metal?
Yes.
Do we use ionic or covalent?
Ionic.
Is it a type 1 or type 2?
Type 1.
Do I need a Roman numeral?
No.
Guys, are you seeing this? This is how quickly you should be answering these questions. Very good, Christina. Does
Thank you.
not need a Roman numeral. All right. So what's the name of the cation?
Potassium.
Potassium. Everything else other than the potassium is the anion. Do you know, have you been able to look it up on the chart?
I'm looking. I'm not real sure how to name it when it has 3 or when it has 2 after, you know.
The whole anion, Christina, is everything other than the cation. So it is Cr2O7. Do you have something like that in your chart?
Oh, I do. Dichromate.
That's the name of the polyatomic.
Okay.
So what's the name of the entire compound?
Potassium dichromate.
Simple as that, guys. It's just that simple. Allie. No, I don't want to do Allie right now. Let me do Malin. Malin, you're out there, Malin.
Yeah.
Okay, Malin. Is the first element a metal?
Yes.
Okay, am I using ionic or covalent rules?
Ionic.
Ionic rules, okay. Is that metal a type 1 or type 2?
Type 2.
Look in the second column, Malin. Do you see Mg somewhere in the second column?
Yes.
So remember, type 1s are anything in the first column, anything in the second column, plus silver, zinc, aluminum, and cadmium. So again, I asked the question, is it a type 1 or type 2?
Type 2.
Type 1s are everything in the first column, everything in the second column, plus silver, zinc, aluminum, or cadmium. Is it
So
in the
type
second
1.
column? It is a type 1. Do I need a Roman numeral?
No.
No Roman numeral. Okay. Name the cation. Mg, do you know what Mg is?
Magnesium.
Magnesium, no Roman numeral, just magnesium. Okay, Malin, Now, everything else is the anion. PO3. Does that have more than one type of element?
I don't know.
What's a P? What's the element P stand for?
Phosphorus.
Phosphorus. And how about O?
Oxygen.
So if there's phosphorus and oxygen, that sounds like there's more than one kind of element there. Doesn't it, Malin?
Yes.
So if it's more than one type of element, you got to look to your polyatomic chart. Do you see something in your polyatomic chart that looks like PO3?
I don't have my polyatomic chart up.
Okay, guys, please get your polyatomics because it's not doing you any bit of good if you don't have yourself these readily available to you. Somebody please tell Malin what PO3 is.
Phosphite.
Phosphite. Okay, Malin. So you know the cation is magnesium. You know the anion is phosphite. What is the name of the entire compound? Malin?
I'm trying to think.
I don't know. It's a perfectly good answer.
Magnesium phosphide.
Magnesium phosphite. Yes, absolutely. Armethea. Hi, Armethea.
Yeah.
Ah. Okay, let's look at this one. Is the first element a metal?
Let me see. Nope.
Nope. Do I use ionic or do I use covalent rules?
Covalent.
Okay, do they have prefixes or not?
Yes.
Okay. Now, is there more than one of the first element?
No.
So it doesn't need a prefix.
No.
Name the element.
Carbon dioxide.
I just wanted you to name the first one. Okay. First element is
Carbon.
carbon. Okay. How many of the second element are there?
2.
2. What's the prefix?
Di.
What's the root?
Ide.
No, that's the suffix.
Um,
What is the element?
Carbon dioxide.
Carbon dioxide. Absolutely. Ellie, you out there, Ellie?
I'm here.
Good. Okay, Ellie,
Yes.
is the first element a metal?
Yes.
Okay, which rules?
Ionic.
Okay, is the metal a type 1 or a type 2?
It is a type 2.
What do type 2s need?
Roman numerals.
How do I find the Roman numeral?
I look at my polyatomic anion to the right.
So what's the total negative charge there?
Well, nitrite has a -1 charge and there's a 2, so it's -2.
So what does that mean the charge on the 1 copper has to be?
+2.
So name the cation.
Copper 2.
Okay, look at the anion. Is it composed of more than one type of element?
Yes.
It's a polyatomic. Got to go to your polyatomic chart. What is the name of NO2?
Nitrite.
Name the entire compound.
Copper 2 nitrite.
Guys, you got to practice these things. I can't emphasize that enough. If you look at your survivor guide, it has a ton of questions, for you to look at. If you don't like that, if you're in my lecture, you can use my worksheet for that, for nomenclature. But guys, as quickly as you saw Christina and Ali answer those questions, this is how quick you should be able to answer them. You need to do that by practicing. Jordania. She just snuck in here. Jordania. Okay. Lewis, are you out there, Lewis?
Yes, sir.
Okay, Lewis. Is the first element a metal?
It is
It is a metal. Do I use ionic or covalent?
ionic.
Ionic. Does that mean I'm using prefixes or not?
No prefixes.
No prefixes. Good. Okay. And nickel. Is it a type 1 or type 2 metal?
Type 2.
Is it in the first column, Lewis?
Yes.
It's Ni is in the first column.
No, it's not.
Is it in the second column?
No.
Is it silver, zinc, aluminum, or cadmium?
No.
So that's why you know it's a type 2. What do type 2s need?
The Roman numerals.
Roman numeral. I get the Roman numeral by determining the
charge.
The charge. Okay, I do the charge by figuring out the charge on the anion. All right, Lewis. N. That's the entire anion there. What's the charge on N?
Is it -3?
Perfectly good. Absolutely. So if the anion is a -3, that must mean that the cation must total up to be
3.
+3.
Mm.
But Lewis, how many nickel atoms is that +3 distributed amongst? How many nickel atoms are there?
3.
Lewis?
3.
3. So the whole +3 is distributed amongst those 3 nickels. What's the charge on each one?
The charge for nickel, I don't know.
Okay, Lewis, you
Yes.
said the whole charge was a +3, right?
Right.
That's distributed amongst 3 nickels.
Oh,
So
one.
what's the charge on each one of the nickels?
1.
1. All you got to do, Lewis, once
Okay.
you find out the total positive charge, divide that by the subscript on the cation. That will tell you what the charge is on each one. So you just determined that the charge on the nickel is a +1. Name it.
Is it nickel night?
No, I want you, remember, you said type 2s need a Roman numeral, right?
Right.
You just went through all that to figure out that nickel has a +1 charge. You ought to use it.
Is it nickel? No.
1. Nickel 1.
Nickel 1.
Okay, do you see the nickel has a +1 charge, so the Roman numeral is a 1.
Okay.
All right, you
Okay.
got that?
Yeah.
All
It's
right,
confusing because of the 3, so that's why I was like,
I understand that. There's a tendency to look at the 3 and say, oh, that should be a Roman numeral 3. That's not the way it works. The way it works is you want to have the charge as the Roman numeral. So this is not nickel 3. This is actually nickel 1. Okay, Lewis?
okay.
All right, now we got to go for the anion. Is it composed of more than one type of element?
No, it's just one.
So we name it by taking the first syllable. What's the name of the element?
Nickel 1.
No, that's nickel 1. That's the cation. I'm looking at the N.
Oh, it's just nitrogen.
Nitrogen. What's the first syllable? Okay, if you don't, syllables, let's see. How do I describe syllables? Syllables are when you pause when you're saying a word. Okay, like if I'm going to say silver, the sil is the first syllable, the ver is the second syllable.
Oh, ni.
Ni, end it with IDE.
Nitride.
Nitride, nickel 1 nitride.
Okay, because I was thinking the N or the 3 would be with the N, so I was thinking of tetra and then.
No. It's got nickel in there. Tetra is a prefix. You never use prefixes if you have a metal. Okay, Lewis? All right, I'm going to go through, and what I'm going to do right now is I'm going to go through the acids real quick. Oh, I got to do something else first. We have to go things in reverse, guys. That means what we've been doing to this point is we've had the formula, we've been determining the name. Now we got to go it the other way around. We have to go from the name to the formula. Okay, if the name is copper 1 oxide, okay? First thing is easy. You got to figure out what the elements are. It ends in IDE. Now, there are some polyatomics that end in IDE, such as hydroxide cyanide. But more normally speaking, IDE will indicate that it is a monoatomic ion. If it sounds like it should be one of the elements that are nonmetals, then it probably is. So I've got copper and oxide, copper and oxygen. It's copper 1. Guys, look at it. That 1 tells you there's a +1 charge on the copper. Oxygen has a -2 charge. So you can look at that. You can do the cross thing and know that the charge on the cation will be the subscript on the anion, and the charge on the anion will be the subscript of the cation. You can do that cross thing, or you can figure it out by charges. The whole molecule is neutral. If oxygen has a -2 and copper is a +1, I obviously need 2 coppers. So the subscript on the copper is going to be copper 2 oxide. If I'm looking at a covalent compound, these things are easy, guys. All I got to do is look at the prefix. That tells me how many of that element there are. Trichlorine, that means there are 3 chlorines, Cl3. Tetra means there are 4 iodines. So the compound formula is Cl3I4. Allie? You didn't see that. Dihydrogen monoxide. What is the formula?
H2O.
There you go. You'll never hear it called dihydrogen monoxide, but that is its formal name. H2O, it's water. Christina.
Yes.
Again, you didn't see that. Magnesium nitrate. I want the
So-
formula.
MgNO2.
Nitrate,
Oh. MgNO3.
NO3. But what's the charge on the NO3, Christina?
Oh, so it's Mg2NO3.
Nope, nope.
No?
Mg has a +2 charge, NO3
Oh, it
has a
has a -1.
-1.
Okay, so MgNO2.
No.
Way off then. Okay.
Okay,
It's been a really long day.
Christina,
Mm-hmm.
put the things together first, all right?
Okay.
You know it's Mg and you know it's NO3,
Right.
okay? Now you got to figure out the subscripts. Now, you can't break up the NO3. That's
Right.
like a family. They have to stay together, okay?
Mm-hmm.
So you have Mg +2, your NO3 has what charge?
-1 or -1.
So you're going to need 2 nitrates or you're going to need 2 magnesiums?
2 nitrates.
2 nitrates. Now name it.
So Mg and then parenthesis NO3 2.
There we go. Okay. Armithia, you want to try one of these?
Yeah.
All right. Aluminum acetate. Okay. Does it end in IDE, Armithia?
No.
No, it doesn't end in IDE. If it doesn't end in IDE, it can't possibly be a monoatomic. So you're going to look at your polyatomic chart. Acetate. What's the formula for acetate?
C2H3O2.
Okay, now, do you remember what the charge on the aluminum is?
+1.
Nope. It's a plus, it's a metal.
+3.
+3. Okay. Now, you had the acetate on the chart. What was the charge on the acetate?
-1.
-1. So remember, you got to make these things balance. I want to have a total charge of 0.
I need 3 of them.
You need 3 of what?
The acetate.
So I'm going to take my acetate and close that in parentheses.
And a subscript of 3.
And put a subscript of 3. Am I going to need a subscript for my aluminum?
No.
And there we go. That is aluminum acetate. Good job.
Thanks.
Okay. I've been working on this for now about an hour. I'm going to go through acids and then I'm going to consider this a workshop area, okay? Now, all acids begin with hydrogen. There are only 2 compounds I know of that begin with H and are not acids, and that is water, H2O, and peroxide, H2O2. If it begins with H, it is an acid. There are 2 types. The first type is binary, H and a nonmetal. The second type are oxyacids, H plus a polyatomic that has oxygen in it. Okay, so you're going to look at your acid. If it's just got H and a nonmetal, that means it's binary. You start the name with hydro. The root is based upon the anion, the first syllable. So if I have HCl, that would be hydrochlor, add IC, hydrochloric, then add acid. HBr, the Br is bromine, hydrobromic acid. Hydrofluoric acid. Let's go backwards. Brian, you out there?
Yes.
Okay. Hydrofluoric acid. It ends in IC, so it's probably a binary acid. It is a binary acid.
Okay.
I'm sorry. Let me erase that. It's got hydrofluoric acid. It's got the first syllable of a non-metal there.
It's fluorine.
Fluorine. So what is the overall formula?
HF.
See. Mila, you out there?
Me?
Yep,
Well,
you.
With an M? Yeah.
Okay.
Sorry.
Hydrosulfuric acid.
Okay.
What element does that sound like?
I'm not sure.
Okay, somebody help her.
Sulfur.
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 Okay.
So this means I have hydrogen mixed with sulfur. What's the charge on sulfur? Anybody?
1.
Nope.
-2.
-2. So how many hydrogens do I need to balance that?
2.
2. So my formula is H2S. Oxyacids. These are oxyacids. What do they have in them, guys? Oxy. What's it sound like?
Oxygen.
Oxygen. Oxyacids never use hydro. So if you see H followed by a polyatomic with oxygen in it, never use hydro. Now you got to remember this mnemonic. I ate it and it was icky. If the polyatomic ends in ATE, drop the ATE, add IC. H, C2H3O2. The C2H3O2 is acetate. Drop the ATE, add IC. This becomes acetic acid. H2SO4. SO4 is sulfate. Replace the 8 with IC. In this case, sulfic acid just doesn't roll off the tongue. So they added another syllable. So H2SO4 is sulfuric acid. H3PO4, phosphate. Again, phosphate just doesn't roll off the tongue. They added another syllable, phosphoric acid. So if I have NO3, underneath there, NO3, what's the polyatomic?
Nitrate.
Nitrate. So I want to drop the ATE and add IC. What's the name of this acid?
Nitric acid.
Nitric acid, absolutely. Now, if you didn't eat it and it wasn't icky, if you took a bite and it was delicious, if the polyatomic ends in ITE, the acid ends in OUS. H, NO2. NO2 is nitrite. Drop the ITE, put in OUS, it becomes nitrous acid. HClO. ClO, hypochlorite. Change the ITE to OUS, hypochlorous acid. Going the other way. If I'm looking at chlorous acid, ends in OUS, that must mean the polyatomic ends in ITE. So you change the chlorous to chlorite. Chlorite is ClO2. It has a -1 charge, so the formula is HClO2. Again, with HPO3 and H2SO3, they added an extra syllable. Instead of phosphorus acid, it's phosphorus acid. Instead of sulfus acid, it's sulfurous acid. Pretty much, guys, that's all I have. I've been sitting here talking about for an hour and a half now. I'm willing to stay here. If you have questions about anything, I'm more than willing to stay here. But Mayla's just about ready to grab a pillow, I can tell.
I'm sorry, it's been a long day. I just drank a cup of coffee too, and I'm still exhausted.
I know the feeling.
Sorry.
I have one question about the lab.
Gotcha.
When we're going through like the normal labs, I'll just go through the paperwork and write everything down. That way, once you get to the lab, you can just kind of answer the questions. Is that going to be the same situation? Like, can I go through the lab work and go through it?
Christina, I don't remember.
Okay.
And it's been a while since somebody's asked me that question. So we are going to, nope, it's not here. Crap. Stop share. You got to find it first. Did I kick myself out of it? Yes, I did. I kind of did. Okay. All right. All right, so I actually have to look at the lab manual myself to answer that question. And nomenclature. All right, so here's this, Christina. Okay, basically it goes through all the kind of crap that I just went through. Okay, first couple, NABR, K2O, BA3, P2. All right, so just remember those. Christina, I'm hoping against hope that that is the correct.
Yeah, that would save a lot of time, I think.
Well, you think he cares about saving you time?
No, I mean, just in my brain,
Yes.
you know what I mean? If I can write it all out first and then go through and answer questions, that's awesome. Okay.
Christina, from the first one matches up, second one matches up, and the third one matches up. Okay.
Perfect. Yep.
So
Perfect.
I just wrote down the first three. They match up. I'm making the assumption that the rest will match up too. If not, you can curse me out later. Okay.
Yeah, I'll let you know. Thank you.
That'll be when I shiver in the middle of the night, right?
Yeah, that's it.
Basically, guys, I don't have anything more unless you have questions.
I'm going to go ahead and log out. Have a nice weekend. See you on Tuesday.
See you on Tuesday. Take care, Christina.
Have a good
Alethea, you
night.
doing okay? Andrew, you doing okay?
Yep.
Yep.
Ellie, stay after class for a second, okay? Nothing bad. I just want to say something. Aaron, Kaylin, we doing good?
I have a question.
Okay, Kaylin.
I know that we get one lab dropped. The lab that I have dropped right now is not my lowest graded one. Will that
Yes, it
update
is.
later or
Yeah, yes, it is. Trust me.
doesn't seem like it? Okay.
I believe me, Kaylin, I've been through this about 50 million times.
Okay.
It will, I promise you, it will be the one that drops. The lowest
Okay.
one will be the one that drops.
That's all I needed.
It may
Thank
seem
you.
like it's not, but it is.
Okay.
All right.
All right. That's it. Thank you.
Take care. I will check on it for you, Kaylin, but I'm
Okay.
fairly
Yeah, it's
sure.
only like less than a point, but thanks. Have
You're
a good
welcome.
night.
Allie, I just wanted to thank you because I depend on students like you when things are
Super.
struggling. Okay. So I just
Okay.
wanted to thank both you and Christina, and Christina wanted to get out of there as quicker and possible. Okay.
Yeah.
So again, I just wanted to take the time to thank you.
Oh no, you keep us on our toes, which I like. I think, when you're an older student coming back and you actually have to pay for the class out of your own money. I'm like, I'm trying to learn.
I mean, honestly, I had you guys back to back, and you were like this with those answers. And
Yeah.
they don't understand that they have to be like this, because if they're sitting there trying to figure this stuff out in the middle of the test, they're wasting time.
Mm-hmm.
And oh well, anyway, I just wanted to give you that comment.
Well, I appreciate it. Thank you very much.
You take care, and I will see you next week then, okay?
Yes. Thank you very much for your time.
No problem. No problem at all.
Good night.
Good night.